In this lesson, we're going to talk about rotations on the coordinate plane. This is another rigid transformation. So a rotation is simply just a turn about a fixed point called the center of rotation. Now for this lesson, we are going to rotate about the origin. We're also going to assume that our rotation is going to be counterclockwise unless noted. So the default for rotating a point or an image is counterclockwise, which is going to the left. Sometimes they may be rotated clockwise, but if it is not stated, just rotate counterclockwise. Here are some properties under a rotation, and the main idea is that it is a rigid transformation, meaning the result after the transformation, after the rotation, is a congruent shape. All corresponding sides are congruent and all corresponding angles are congruent. Again, this is a rigid transformation. So let's talk about the rotation rules. And again, we're going to focus on counterclockwise. We will take a look at the rules for clockwise. But as you can see here, our blue triangle is in quadrant 1, and this is our pre-image. We are rotating about the origin, and in this rotation, we are rotating counterclockwise 90 degrees. So when you rotate 90 degrees, you move one full quadrant. So we went from quadrant 1 to quadrant 2. So we can identify a point. Let's start with this point here. This is 3, 5. The end result after the rotation is -5, 3. What happened was our x value did not change the sign. It stayed what it is. So when we go 90 degrees counterclockwise, the x coordinate stays its value that it is. The y coordinate changes to the opposite value, and then the two coordinates switch places. So here is the rule for a 90-degree rotating about the origin. This is an O, a capital O. So we are rotating, capital R for rotation. Then the subscript is O, 90 degrees. We are rotating about the origin and we are going counterclockwise. The rule is the x coordinate stays the same, the y coordinate changes to the opposite, and then they switch positions. Now let's take a look at rotating about the origin counterclockwise. Again, we are in quadrant 1. We are going to end in quadrant 3. We are rotating 180, so that is 2 90-degree rotations. So that means we are moving 2 full quadrants to the left, again, counterclockwise. So this time, let's take a look at this point. This point is 2, 1, and then we end up at -2, -1. So the rule for rotating 180 degrees about the origin, the coordinates do not swap positions, they just change to the opposite value. So here is the rule for rotating about the origin 180 degrees. Both the x and y coordinates change to the opposite. Now let's take a look at a rotation about the origin, 270 degrees. That is 3 rotations of 90. So we move 1, 2, 3 quadrants about the origin. We started in quadrant 1. We end in quadrant 4. And again, it is very good to notice what type of coordinates you should end up with. So we know that this is positive, positive in quadrant 1. Again, 3, 5. And then when we get to quadrant 4, we should end up with positive, negative. So always keep that at the forefront. So here we're going 270, and our ordered pair is 5, -3. So this is the inverse of 90 degrees. In this case, the x value changes to the opposite, the y value stays the same, and then they switch places. So we have 5, -3. Again, noticing what type of coordinate that your object is going to land in, the quadrant, you need to understand what type of coordinate you're going to have, what sign you're going to have. Now let's just take a brief look at clockwise. So clockwise is just the opposite of counterclockwise. So this time our 90-degree rule is going to be the opposite. So this time, instead of going to the left, we are going to the right. We are in quadrant 1. We're going to end in quadrant 4. So we're going from positive coordinates to positive negative. So the clockwise rotation for 90 is the same rule as counterclockwise for 270. So here we have 3, 5, and then we're going to change the x value to its opposite. The y value is going to change, and then they're going to switch places. So we have 5, -3. So here is the rule for rotating about the origin, but we're going clockwise this time. So this rule is the same rule as counterclockwise 270. When we do a rotation about the origin going clockwise, we start in quadrant 1 here. We're going to end in quadrant 3. And so what happens here is our ordered pairs, our coordinates of our ordered pairs, they just turn to their opposite value. So this point is 2, 1, and then we get -2, -1. So when you rotate clockwise or counterclockwise, it is the same rule. The x and y coordinate, they do not change position, but both coordinates are negated. Now the rule for rotating about the origin, clockwise, 270, we are going from quadrant 1 all the way to quadrant 2. So this rule for 270 clockwise is the same rule as going 90 counterclockwise. You can see if we were going counterclockwise, I would just go 90 degrees and end up in the same quadrant. So our rule is going to be our x is going to remain the same value, the y is negated, and then they switch position. So we have -5, 3. So here is a little summary of 90 degrees counterclockwise. Then we have 90 degrees clockwise. And then the 180, either direction you go, it's the same rule. And then we have 270 counterclockwise. And then it has an opposite rule clockwise. So please take note that this rule is the same as this. So if you're going counter 90 or clockwise 270, it is the same. As well as if we go counterclockwise 270, which is 3 quadrants around, it is the same as going clockwise 1 quadrant of 90 degrees. Now remember, we are going to stick with counterclockwise unless otherwise stated. So here we have our pre-image. A is 1, -2, B is 1, -6, and C is 5, -6. Again, we are going to go counterclockwise, which is to the left, so we're rotating this way. We're rotating about the origin, and we can see that A prime is 2, 1, B prime is 6, 1, and C prime is 6, 5. So we notice that our x values 1, 1, and 5 remain the same. 1, 1, and 5, they just switch positions. And then the y values, the y coordinates changed to their opposite values. So this was a rotation, so capital R, about the origin, and it went 90 degrees. Now, sometimes we may not put the origin because we're going to assume that this lesson is rotating about the origin. Here we're going to start out in quadrant 4. We're going to quadrant 2. So we have positive, negative values, and we're going to end with negative, positive. So we can just see that our coordinates are going to be negated and they're not going to be switched. So A is 1, negative 2, B is 1, negative 6, and C is 5, negative 6. A prime is negative 1, positive 2, B prime is negative 1, positive 6, and C prime is negative 5, positive 6. So our coordinates did not switch positions, they were only negated. That meaning their sign turned to the opposite. So this was a rotation about the origin of 180 degrees. And again, we're going counterclockwise, but even if we went clockwise, it would be the same. Okay, this time, again, we're starting in quadrant 4, which is positive negatives. We are going 1, 2, 3 quadrants around to quadrant 3, which is negative, negative. So going 3 quadrants is a rotation about the origin of 270 degrees. So 3 quadrants of rotation is 270, where moving 2 quadrants is 180, and rotating 1 quadrant about the origin is 90 degrees. So our A is 1, negative 2, B is 1, negative 6, and C is 5, negative 6. So the rule is when we're doing 270, the X values are negated, the Y values stay the same, but they switch positions. So sometimes this is how I like to do it. I know that my Y's going 270 counterclockwise, they stay the same. They just move to the X coordinate position. So I just write those in, and then my X coordinates, they change to their opposite and they move to the Y coordinate spot. Okay, now let's do some rotating ourselves. So unlike translating and reflection, for me, rotating is a bit difficult doing it graphically, so I'm just going to apply the rule and then plot the points. So we have A is 1, negative 2, B is 1, negative 4, C is 6, negative 4. So I'm going 270. I'm going to go counterclockwise. So 270, the rule is our Y stays the same, but moves positions, and then the X coordinate changes to the opposite value. So again, we are in quadrant 1. This is very important to go ahead and identify. We have positive, negative values. We're going all the way, and we're going to end in quadrant 3, which is negative, negatives. Okay, so again, the Y's stay the same. They just change positions. Our X's are negated, and they change the position, moving to the Y coordinate. So I think I have this right. Okay, so we have negative 2, negative 1. So this is A prime. We have negative 4, negative 1. This is B prime. And we have negative 4, negative 6. And this is C prime. So applying the rule algebraically and then plotting the points makes it easier for me anyway. Okay, here we are. We are in quadrant 1 where we have positive positives. It says to go 180. It doesn't matter if we go counter or clockwise. Let's just remain going counter. So we're going to move into quadrant 3 where we have negative, negative. So we know that our values are going to be negated and they are not going to switch position. So A is 3, 7, B is 3, 3, C is 5, 3, and 180 degrees about the origin counterclockwise, our coordinates are just negated. So A prime is -3, -7, B prime is -3, -3, and C is -5, -3. So let's plot these. So we have -3, -7 right here. We have -3, -3. Oh, let's label that. Let's not forget that. Very important. Make sure you put your primes. And then we have -5, -3. And then we have our triangle. And there you go. Okay, let's do a 90 degree. So we are starting in quadrant 4, which is positive negatives. We're going about the origin and we're rotating counterclockwise. So we're going to end up in quadrant 1, which is positive, positive. So A is 4, -2, B is 4, -6, and C is 6, -6. And the rule for going counterclockwise 90 is the X value stays what it is but moves places, and the Y changes to the opposite, and it is switched to the X coordinate. So set these up. Our X's stay the same, they just move to the Y position, and then our Y values are negated, moving to the, to the X position. So all positive. So again, we are right, positive, positive, that's what we wanted. So A prime is 2, 4, B prime is 6, 4, and C prime is 6, 6. And then we have our triangle rotated about the origin, counterclockwise, 90 degrees. Now, if we were going clockwise, like a clock, this would have been a 270-degree rotation. Okay, now let's just apply this rule, and we don't really need a graph. So here we're going 90 degrees. Again, we're going to do counterclockwise. So 90 degrees means the X value remains what it is, and then the Y is negated and they switch positions. 180 degrees about the origin counterclockwise, both the X and the Y coordinate remains in the same position. They are just negated. Oh, and let's go back right quick. So here we were in quadrant 4. We're going 90 degrees counterclockwise, and that will put us in quadrant 1. And we do have the right type of signs. In this example, we were in quadrant 2. We were going halfway around the coordinate plane. We were going 180. We would end in quadrant 4, where we should have positive, negative, and indeed we do. So here we have point Z, and we are in quadrant 4. We're going 270. So if we're here, 270 is going to put us here, which is quadrant 3, and we need negative, negative. So the rule for 270 is the X value changes to the opposite, it's negated, and it switches spots, and the Y value remains what it is, it just moves to the X position. And this is exactly what type of coordinate we needed, negative, negative. Okay, this time we are going to write the rule. So we started out at 7, -3. 7, -3 is quadrant 4. It's down here. We are going to end up with negative, negative, and they did switch places. So that means we are going to end up going 270 degrees counterclockwise and end up in quadrant 3. Here we are in quadrant, it looks like 2. So negative, positive, that's somewhere here. I'm not going to plot the point, actually. I'm just saying what quadrant we're in. And then we're going to end up with -8, -5. So that puts us down here in quadrant 3. So that was a 90-degree rotation. So even if you don't have this coordinate plane, you can simply always draw yourself just a simple little coordinate plane, and this will be very helpful. Okay, here we have Z is in quadrant 4, and it looks like we're going to end in quadrant 2. So we were somewhere here, and then we're ending up here. So that is 180 degrees about the origin.